way. So spot on with the seats, the people that put them out. There's one and there's one person standing, so awesome. Hello everyone, I'm Matt.
I'm David.
I'm David. And we organise Infracoders, and we're here at ThoughtWorks today, and we have 2 talks today from Info Exchange and also REA Group. So yeah, it's really good.
So the format of tonight, we usually kick off with a bit of an introduction from the hosts. They're welcome to talk about what they do. And we'll do the 2 talks, and then there'll be some food arriving, I believe, which is a very special thing tonight. And then we do a sort of community announcements. If you're looking for a job or looking to hire, then your chance will be at the end. And then that's it.
So Tom from ThoughtWorks.
Hi everyone, my name is Tom, I work for ThoughtWorks. Welcome, we've got a new office and this is it. So those of you who've been coming to these things will have seen ThoughtWorks rattling around. You know that probably most of you know we do mostly dev, but we're doing a bit more dev and ops. So I'm helping do dev and ops things in ThoughtWorks. So we do consultancy for our clients, and if you would like to be a client, then you can phone us up and we'll send you people who can make your things better. Or you can come and work for us, but we'll talk about that later. This is our new office, and as you can see, it's got like a snazzy kind of like big space where you can have user groups and things. We're really keen to, like, given that we're paying the rent, to like use this space. So thank you all for coming. Also, if you go to other user groups that are maybe not just Infracoders, I do believe there are other meetups in Melbourne.
I think, don't know if you know.
Not Tuesdays, because why would anyone do that? So if you do go to other user groups and you're looking for space, then here is a space that you're welcome to come and use, and we have beer and food and all that sort of thing. So please come and abuse our facilities. I have one more request of you before I go and sit down, before Matt hits me. Next week is the Agile Australia conference, which isn't really the biggest cheese in the land of DevOpsing or the DevOps. There will be some DevOpsing things going on, so if you're going, hurrah, you will see some relevant stuff. It won't all be about, hey, we did a Scrum and now the world is great. There will be a panel talk on Tuesday, a week today, at 11 AM, around data privacy and the Snowden revelations and cool things that we can do about it. Without wanting to kind of self-publicize too much, I will be there. So we'll Senator Ludden from the Greens, and John Lawrence from Electronic Frontiers Australia, and we'll be talking about why privacy is a good thing, and discussing like tools and stuff around encryption. This feels quite relevant to sort of dev and opsy people, so if you're interested, please come. If you think you know people who would be interested, please tell them, and then bring them with you.
So when is it?
11:30 week today at Melbourne Conference Centre.
We'll post it on the Meetup group.
Yeah, it's on the Agile Australia site. It's a public, free forum, like it's in the conference, but it's set apart, so you don't have to pay for a conference ticket. Anyone can come, and you can get shouty about George Brandis. Like, what more could you ask for? Anyway, so enjoy the talks. We'll have some food arriving probably about sort of 6:30, 7-ish, so we'll get through the 1 or 2 talks before then. But yes, have a lovely time.
Ross and Alexi. Yeah, correct. And they're going to talk about Docker and pallet and forklifts and all kinds of warehouse things.
Hello. Yes, as you mentioned, Alexi and Ross from Info Exchange. Our motto is technology for social justice. What that means is we do a lot of stuff, but part of what that is we do online applications for governments and other not-for-profits, provide services to other not-for-profits. We do much more than that, but that's the side of things that we're focusing on.
Yep.
And yeah, we'll get into our Docker adventure.
Yeah. So what we have is a wide range of web applications. We are mainly using Django and Python for the new code, but it's been quite a while, and we've got a few legacy Perl applications that are quite tied to the Apache. We've got an enterprise service bus, which is also on Python. We've got we would very much like to have an in-house continuous integration server. We would like to have Python 3 sooner or later. And so it's a pretty diverse mix. I'll be mainly using the Django application as the basis for what I'm explaining here. So what we have is Apache using more WSGI. We have virtual apps, managing dependencies. We have South for database migration. That's pretty standard. And we have problems. So we need the other libraries which we must install on the server, such as libsml or correctly, whatever it be. We've got some problems with uninstalling some libraries in Python. We used it, now we don't want it. It left some craft over there. How do we uninstall? It might be managed in some way. For the front-end kind of thing, we're using Bower to manage JavaScript dependencies. To install Bower, we must install npm first. So that's kind of complicated. Systems are joking at us, developers, that we've got like closer to 11 package managers. I don't know how they're counting, maybe in binary, but it's a problem. And here's what's the problem.
Yeah, so the puppet manifest that we had to deploy all this stuff, they were pretty terrible. So we had a separate one for each application, more or less. It started with the best of intentions. It sort of degenerated or organically grew, okay, into a pretty much unmaintainable mess. So devs would say, hey, we need this new package manager. We're going to go, okay, well, how do we fit that in? Probably it's another exec out. Huge chain of execs, what a mess. And the other cool thing was, if GitHub's down, we can't deploy to production. So that's great.
Yeah. So for the development work, we used to have VMs. The VMs were close to production as close as possible. That meant that they're also Puppet controlled. And Puppet liked to do interesting stuff, like rolling back our work to the last commit or whatever was tagged or whatever it was. I don't quite remember the details. It didn't happen often, but it was still a problem. And so what we wanted was mostly inspired by 12 factors. If you don't know what 12 factor is, go and check it out. It's a very dope thing, and it's basically a must read. What we want is to have a deployment framework which can deploy all our diverse applications, which can deploy them without downtime, ideally, and without failing in the middle and leaving everything in some failed state. So the application doesn't work because it didn't deploy, and then nothing happens. We want to be able to do clustering so that we scale nicely and so that we can work on one server while, provisions or something. And we want to have a clear separation of who's responsible for what's the developer's responsibility, what's open responsibility, so that we're not blaming one another for stuff that's related. So Docker. Docker is the answer to everything. You just run this command, and you've magically got everything under control. Right? Right. Right. You got an image, you build it, you run it, and what? So, given that we're doing web applications, this probably starts a web server. Now, it probably starts a web server on port 8000, or maybe 9999, or maybe 5000, or maybe 8080. I've seen all those. And then it's a web application, it needs a database. Where is the database? I don't know. And it's a web application, we want to scale it. How do we, is it safe at least to launch more than one of these? What happens if we want to have a new version of these? What do we do? So we came up with an application lifecycle that from the DevOps point of view. We have test, which is probably a point for another talk, but let's run the application unit test. And then we got deploy, which does some one-off initialization task, such as migrate the database to the new version. If you think for the Python, we go south migrations. And then serve actually starts the web server. So what?
It's good. It's fine.
Great. So what happens is Puppet would create a deploy container, which will do whatever it needs to do, and then exit. And then another container will be created. That's a container we don't care about anymore. It can be later or what. And then we create another container and run serve, and then tell the load balancer to proxy the request to it. When we want to deploy a new version, that's fine. When we want to deploy a new version, because the old server is still running, and maybe we have more than one of these. So we can scale them. If we want more requests, we just start many of the servers. Because the new deploy, which updates the database schema and does whatever it needs to do, and we start the new server, serve 2, and then the load balancer first adds the second one, and then removes the first one. And the worst that can, there's no downtime here. The worst that can happen is that server 1 can't work with the new database schema. That's the risk we want to take, because otherwise that's really the minimal interruption we can have. We have a rule that do not do that, because otherwise that'll be much harder. How are these Docker containers configured? Everything is inside the environment variables. We have the URL passed to the container from Puppet. We have the environment types, such as production staging, which basically controls the login. Nothing, just we want to be close to each other. We have the number of workers. We have all the services which we want, such as database, Elasticsearch. We're using Elasticsearch, so we want a URL for that. We'll use Logstash for the login service, so we want a URL for that. We use email, like we want to send outbound email, so we want a URL for that. Everything specified as an environment variable. And some conventions, well, we just had to set them. We've got to serve on port 8. We've got to have /storage for something that we want to save. Because there's more than one container, you'd actually want to ensure that files uploaded to one don't end up just to the container, because the container will be destroyed, actually. And /static is something that we don't really want to go to the container application server, we just want the load balancer to serve it. Whatever we copy there will be served just like the Nginx.
All right, so bearing in mind all of that, from an ops point of view, this is how we've started to implement it. So, well, there's tons of options, and actually pretty much every day someone else has come up with a new option, put it on GitHub for doing this sort of thing. We have a small team, so it's not really an option for us to go with the systemd type of things, because we've standardized on Debian. And Debian stable is not yet ready for systemd. It'll be getting there, but not at this point. So what we've come up with instead, init script. Sounds awful. It's really not that bad. It started out entirely in Bash. That got out of control fairly quickly, but luckily we put a cap in that. So it's now it now calls out to a much nicer Ruby script to do the heavy lifting. It's using this Swaply's Docker API gem. So that means it does all the talking to Docker, and I don't have to worry about what initially happened with the Bash script was I was just taking the output of Docker commands and trying to work with them. But then, of course, a new Docker version comes out and breaks everything. That's no longer a problem. And to actually work in a cluster, we use Surf. So Surf's just a local protocol for communicating events and state of the cluster. Yeah. So to configure what we're going to run on our systems, we use Hire with Puppet. So we specify all our environments exactly like that. A lot more stuff, but you get the idea. You notice at the bottom here, got wait and min servers that comes back to the Ruby script I was talking about earlier, and I'll show you that in a second. Yeah, carry on. And yeah, so now what we're doing is we're using Puppet to deploy configuration rather than trying to deploy stuff with Puppet.
and we can use things like standard service type. So the service type will call status on the init script. That's the human readable output, but obviously it just uses the return code to determine whether everything's happy. You'll see here optimal status is true. If you refer back to the previous slide, you will see that I had min servers set to 2. It's running on 2 servers, so it's happy. And it also happens to be running on this host, but that doesn't seem that's not important. And now it's just like every other Puppet application that you're deploying. Not deploying, just running. Carry on. We don't run our services inside Docker containers, so Postgres and everything else is configured in exactly the same way that we used to configure it. So again, we specify the configuration, they go out, but the higher configuration now, whenever the container goes in, goes and adds all of that, the ACLs and things to the database service to allow that container to communicate with it and have the volumes be able to get their storage mounted and everything else. Yeah, carry on. So now we're happy. We're not dealing with dodgy deployment that we've tried to shoehorn into a Puppet manifest that keeps growing by the week, seems to be, or seem to be anyway. We're deploying configuration. Our infrastructure changes are much easier because we know exactly what they'll affect. Any new features we add happens everywhere automatically. And one of the other, and everything uses the same Puppet classes, so we're no longer maintaining a different Puppet class for every application, or multiple Puppet classes for every application that we're running. And also, especially in terms of contracts that we have with governments and things, our DR procedure is much easier and much easier to test as well.
Yeah, so they're happy. We've just created this nice system of containers so that when you want for development to just run your own container test, you have to just run the simple command and you're going to run a container. It's really cool. But yeah, it's fine. They can script it in Puppet or the Ruby script. But what do we do to develop it? That's the first question that we ask ourselves. And we came up with a tool called Forklift because it's just for managing that one container. You don't want four. So what do we have to know about the application? Our application needs Postgres for the database, and it needs Elasticsearch. Forklift figures that everything out, so we can just give it the container as an image name and what to do. What would happen would be if you have Postgres installed on your local machine, well, say Postgres, Elasticsearch, everything, you'll use that and supply it to the container. Because environment variables, the container already knows how to do that. Elasticsearch, everything, the URL will be localhost, but that's fine. If you don't want to install Postgres on your laptop or whatever it is, it will tell you which container image to download so you can run Postgres from that. That's also fine. If you have some strange configuration on your local machine, that's also fine because you can just provide the configuration for Forklift, and everything will be using that. So we're kind of happy. We're building the containers, we're testing them, and we'll find bugs. And the first thing that we noticed is that you can't really go inside a container and poke into it and see what's failing, what's not failing, what's going on. How do I SSH into it? So there is a special mode in Forklift which ignores whatever a container is doing and installs the SSH daemon if it's not always there. It's like gives you sudo just in case, and does some other tricks, including mounting the container file system on the host so that you can actually go in and poke around. That's also good. But if you're debugging things, then that's also slow because every time you change something, you want to rebuild the container to ensure that the changes go in. This is not always convenient because you still have to copy the files between and whatever you want to do. So you might say that there's a whale in the room. What else? There's no whale. How do you refresh this?
There's a whale gone.
Right, there's a whale. So for Django applications, there's this managed PY, which runs the application server or whatever it is. For other frameworks, there are similar things. So why do we bother with Docker altogether if all that we want to do is just to test our own application? So if you give Forklift the command to run, it will provide all the same environment variables, everything, to the command and run it. That's fast for development, and you can just do that without rebuilding the container all the time. This is how we work now, and oops. Yeah, we are happy, even though the presentation now. We don't get deployments failed because some dependencies failed to install, or someone uploaded a new version and broke things, or someone removed the old version, which even though we logged everything in the requirements file, someone removed it because it needed something and whatever, it's no longer available. We've got a clear boundary. We give the operations container that we want to run, and they run it. We don't get something like it failed in the middle, and then we know what to do. You just run this single command, and they're not really happy with that. We seriously switched our Django applications to G-Unicorn. We didn't need to change any Puppet manifest, nothing changed. We added Celery, the test queue for our Django containers, so essentially the background workers. So while doing that, again, we didn't require any kind of configuration changes. We just put it there, we just edit it to the Docker file and everything, and it runs. We don't really need any system support for doing that. So that was pretty nice. What we'd still like to do would be interdependencies between applications. For example, we have a single sign-on application, and so it would be good for other applications to also have an environment variable to know where should they connect to and how should they interact with them. And that should also pave way for the microservice architecture, which we hope will get. Also, something we're pondering is multiple container types for an application. So we've seen that we run web server and Celery for background task queue, and maybe we should actually be looking at running them in separate containers so that we have better visibility of what's running, what's not running, what requires more resources, and what needs to be load balanced, and so on. So yeah, everything's pretty heavy. Questions? Oh, Forklift is open source, and this is a first slide. Questions? Yep.
How long have you been running Docker in production?
How long have you been running Docker in production? Probably nearly a month now. In production, it's been running for a lot longer than that, not in production, but in production for about 10 years.
How long have you been developing these before?
Probably September, October last year is when we started. Yeah.
Does Forklift make a lot of assumptions on how you use Docker? As in, if you wanted to use this with the other systems such as CoreOS and things like that, does it make the assumptions that you're running?
What's inside the container is irrelevant, but you have to conform to those specifications, such as you'd have to take the URLs.
Yep.
If you don't want to take the URLs, then you might just run Docker itself. What Forklift makes easy is to provide those URLs, discover services on your machine, and provide those URLs, and seamlessly plug them in. I have tried and looked at whether there was something similar, and this is actually the link, the alternatives I've come up with. So you've got Fig, you've got DryDoc, you've got Gaudi, and you've got just basic Docker link. And while they can be used, they're solving a bit of a different problems. For example, none of them has any kind of application management or database pathway. Docker link gives you host and port to connect it to your database. can do that. Can't do any kind of password management, anything like that. And you would know they don't offer you any kind of deploys and serve and hot deploy and clustering solutions. You have to implement that yourself, basically. So all of those we've tried and looked at them. And I'm aware of the other standards, like kind of standards for containers. So Forklift is working with our standard, if you can call it that. And if you want, we didn't really find something that's comprehensive.
There's stuff to help you with furthering the project as well. There's DEIS, D-E-I-S, and also Flynn, and they use Docker, but they very Heroku-like. You give it configuration and it runs a cluster for you and stuff like that.
Yeah, so Gaudi totally does that.
Yeah.
But I think they restrict the kind of containers you can run at all, so you can't just provide your own container. Questions?
Any other questions? That's Docker. Everyone's got questions. Is it in production?
How are you using Slurp to control the cluster of the Docker containers?
Okay. So yeah, it's all mostly controlled by the Ruby script. So as I mentioned in the further back in the YAML, we specify how many servers we want to be running on. And there's another one, weight, that's not that important, but it's basically how heavy the application is. And then Puppet goes and deploys that information out to all of our nodes in the cluster. And then the nodes come along when Puppet runs and when we actually have another monitoring thing on it. It's a bit quicker than Puppet. Once that configuration is there, just use Monit. And it will call the status on that script. And if it determines that it's in a non-optimal state, so it's not running on the number of servers that it needs to be running on, it will first of all say, am I a good host to be starting on, or am I completely busy in flat tack? If I am, then I'll start it myself, and then an event will go out to the serve cluster, and it will say, hey, I've started here. And this is the version of the application that I'm running on me. And it automatically gets broadcast everywhere. That's how Surf works. It gossips out to the cluster saying what I'm running. Well, yeah, it's a tag in Surf, basically. It says, I'm running this version of this application. And then all the other nodes immediately know that that's happening.
What if there's a change to your database that you change the code and you didn't update the database, the structure as well, or do you just not break the database structure?
Yes. So if we need to do that and we know that, then we first must deploy some code which works on both versions and does not change the database. Once that is deployed everywhere, we can deploy the database change. That's really the only way that we can handle this, because inevitably you've got to have either old database new server or new database old server. So we chose new database old server because new server might legitimately expect new things, and we're typically adding more tables or whatever it is, so that's easy to handle.
Question for you, Ross.
Yeah.
What do you think are the hardest problems encountered from ops implementing Docker, and that might be bugs or whatever?
Yeah. So we have had our fair share of bugs with Docker. I mean, they have, until 1.0 was released yesterday, they have said don't run this in production, and we've kind of ignored that. It is supposedly now production capable, but in the 1.0 release, they've actually reintroduced a bug that I pointed out earlier. But anyway, generally they're easy to work around once you know what they are, so we don't just blindly go and deploy a new Docker version everywhere. Yeah, I'd say definitely Docker bugs have been an issue, but it's going in the right direction. I'm quite impressed with the direction that they're going in, so I'm fairly happy with where it's going, but yeah, there have been bugs.
My favorite bug with Docker is that where they change the mode on some directories before they try to unpack the images to 700, decimal instead of 700 octal. And it took a while to figure out, while none of those files were executable.
Yeah.
Oh, well, no, they were executable, just not readable.
Yeah.
Any other questions? All right, thank you.
Straight away.
Yes, I think they're getting the food. It's not pizza, so get excited.
No food before we get going.
It's just the boxes.
So how long will it be before the food is here? Because if it's like 10 minutes, I'm going to have to race through it.
I just think go for it. What do we reckon? It's a democracy. Go for it or wait?
Go for it.
Get another.
It was me expecting to have an opportunity to check it. I just would actually work with this display before I started. But no!
Are you running Linux?
I am running Fedora.
Fedora 20.
What a chance.
So, 2014, the year of Linux on the desktop. Again. All right, let's see now. Where are we?
The future.
Yes, we are in the future. Infracoders.
We're somewhere near a crack.
One thing I'm not trusting myself to, though, is whether LibreOffice can actually keep going for the entire presentation. So I have cheated and made it into a PDF, which I will be paging through. I really kind of wish that I had, no, where does it think it is? There it is, here we go. I really wish that I had had a, one of those remote clicky Watsons. Because I'm hammering through these at a reasonably decent rate. So what I might do, just make it volunteer. Oh, it's all right. I'll because I may want to go forwards and backwards. And
Oh, okay.
So I will do the thing my wife. I'll do the thing my wife hates. I'll balance it curiously on the edge of this obviously stable element here. So my name is Colin. I work at realestate.com.au, REA Group. I'm here to tell you about Credulous. So I splurged and I bought the credulous.io domain, so I'm one of the cool kids now. You can go to credulous.io and read all about Credulous. I apologize for the design. I am not a designer. We have a Twitter handle as well. Oh my God, we're with all of the things. But myself, non-specialist, and Mike, who's sitting at the back there, who was very kindly offering to be my assistant, the maintainers and, I guess, instigators of Credulous as it began. So first up, have you ever had this particular problem or heard of anyone who's had this particular problem? You have some tools. So your tools need some credentials in order to work, and that's great. In order for your tools to work, the credentials, of course, need to be in plain text. There's no point passing encrypted credentials into every single one of your tools. You have them in environment variables. You're being very sensible. And at some point, someone thinks, you know what, I'm really sick of typing these credentials in every time I start an application, so I'm going to save them to disk. Reasonable. Once they've been saved to disk, people tend to do things like put them in doc files, and they put them in with projects, and then they get committed to a source code version control repository, and then someone pushes them to GitHub. And all of a sudden, you have an instance that you didn't start, and then you have another one, and then you have some more, and then you have some more, and all of a sudden, ooh, Amazon wants all of your monies, and then you're sad. So either you're the pride financier for a couple of hundred Bitcoin mining instances, or someone's just walked off with your proprietary confidential data. Now, this sounds ridiculous, and it makes you sad, but it actually happens. So this is one example. Just recently, a company named DrawQuest, which was a cloud-based application that ran on iPhones and Android, and people would do drawings for each other, and DrawQuest would save the drawings. There were subscription plans and things like that. DrawQuest suffered a credential leak, and they determined that after examining everything that had gone on, they could no longer trust any of their internal data. And they didn't have the time and the resources. It would have cost way too much to actually determine what had been corrupted, and so they shut down. That's an extreme end of the scale. But at the other end of the spectrum, there's just large financial costs, there's leakage of proprietary, confidential, personally identifying information, or even sensitive data could happen. So, it's difficult to manage your credentials securely. If you're starting off simply, you only just started using Amazon, maybe you have one AWS account, you maybe have a few users, they all have their own credentials, you're kind of hoping that they're looking after them fairly well. And that's, you know, difficult, but you've got people you trust, and that's cool. It's really difficult when you start to expand and you realize that you're better off organizing your environment into tens of AWS accounts, and you have hundreds of IAM users. So everyone says, and all of the documentation says, store your credentials securely. Excellent. How do I do that? No one says, just do it securely, because duty of care, absolve. Oh, you weren't storing them securely. Not our problem. We did look at a bunch of other things to solve this problem. We looked at identity federation. Those of you who have played with identity federation know how many moving parts there are. We played with SAML. Ooh, what fun. Assume role with SAML. It's really good, except for the fact that, yes, there are many moving parts. You need some kind of central corporate directory. You need a federation service. You need to set up your trust relationship between your SAML provider and each of the accounts that you maintain and manage, and you need to have mappings and all of this sort of stuff. There's lots of bits that can go wrong, which is great if you're a big enterprise and have lots of people to look after it. But if you want to move fast, maybe it's not. The credentials only last an hour. So if you have people that are using the AWS API from the command line, they're using the AWS command line tool, or they're running scripts which actually poke the API on a regular basis, this breaks their workflow every hour. And the problem with that is that people work around it by doing the worst thing of storing their username and password in plain text in a wrapper script, and then they get pushed to GitHub, and then more say pandas. And it's not even supported by all services. We looked at the Get Federation token mechanism, which does allow you to have credentials that last for a lot longer than an hour, up to 36 hours. And that was nice, except that the token vendor, when you authenticate to the token vendor, it needs to have a superset of all of the privileges that you might want to grant to an authenticating user. Which means that if you want to federate the identity of your administrative users, then the token vendor system needs to be a full administrative user. And it has to have persistent IAM credentials, which makes it a brilliant target for attack. It's also not supported by all services. Just an example, these are the ones from the STS documentation of the services that currently don't support secure token service, which is what actually does the federation part of the identity. So Elastic Beanstalk and MapReduce are probably the big ones there for a lot of people. Workspaces is very new, so that's maybe not quite so surprising, and it's also based more on the Windows end of things. Kinesis does, and that's as new as Workspaces. Mechanical Turk doesn't, but I'm not quite sure how many people are still using Mechanical Turk at the moment. I'm sure people are, I'm not sure. So we thought about this, and we thought we want something that can take your persistent user-based IAM credentials and make them safe, make them secure, get around those federation problems at the same time. So we wanted to make sure that obviously everything is strongly encrypted at rest. Encrypt your credentials. Well, we want to solve that one. We want to make sure that we're using an ubiquitous encryption method. Now, GPG is awesome at encryption. Public key cryptography, it's very secure, it's been deployed all over the world, but unfortunately, most people, I'm just going to take a blanket statement here, most people aren't using GPG. And there's a little bit of a learning curve to get it set up, and there's a little bit of fiddling around to get it working properly and use it, and the implementation isn't the same on all platforms and stuff like that. So we thought maybe not GPG. We wanted no external dependencies, because the last thing you want to do when you're managing credentials securely is do bundle install, because what's in those gems? What version are you going to get? Who's changed it upstream? We wanted it to be dead simple to use. We want this to appeal to people who are just starting out using Amazon, maybe just doing their first development project. We want it to be powerful and simple enough for people who are expertly coders with a Z. And it has to be trustworthy. We want people to be able to trust that when they put their credentials somewhere safe with Credulous, it's actually safe and we're not running off with them and launching our own Bitcoin mining instances. A side note on encryption, it turns out that SSH RSA keys can be used for encryption as well as signing, just RSA keys. And SSH public keys can be publicly downloaded from your GitHub account, from your user in GitHub, because they're public keys. Light bulb. So, if we use the SSH public key of a user to encrypt the credentials, we can get the public keys from GitHub or off your local file system. Doesn't really matter. We know that everyone keeps their SSH private keys safe, don't they? Everyone has a passphrase on their private keys. And we can do some really, really cool things. So, another digression, I'm going down the rabbit hole here. AWS allows you, with each IAM user, to have 2 sets of credentials that are valid at any one time. They work exactly the same way. They have the same rights associated with them that you do. You can't have any more than 2 at the moment, but 2 works quite well for what we want to do. The credential metadata includes useful things like the username and the time that those credentials were actually created, so we can inspect those credentials and see how old they are, which is handy. Imagine for a second that A is our set of credentials that we're currently using, and I've got them loaded into my environment variables, and I'm poking the Amazon API, and I'm making calls and all of that. And this sort of goes off into the past over here. And I've decided that at this point in time, I want these credentials to no longer be valid. So halfway through this period of time, I create my B credentials, and I start using those. You can think of it as jumping from the A timeline down to the B timeline. And now I'm making API calls and hammering away, and that's all well and good, and I'm using the B credentials. Something that I started a while back, maybe I did a CloudFormation stack, and it's taking a long time to run, and I've set my wait condition handles with a really long timeout. But when those wait condition handles complete, it's going to go and do something else with those credentials, and I can't put the new credentials into the CloudFormation stack. So those have to be valid until the stack completes, but I can still be using my new credentials. Once I've reached the half-life of my new credentials, I create a 3rd set of credentials. These are now deleted. They go away. They're no longer valid. I stop using these, and I hop down to my C timeline, and I'm using my 3rd set of credentials. And so it goes, 4th and 5th and 6th and 7th and 8th. Every half-life of the credential lifetime that we've chosen, and it's entirely arbitrary, because IAM credentials are persistent, they last forever. Every half-life, we can create new credentials and hop down to the next timeline, leaving the remaining half-life for the old credentials to finish up doing whatever it was they were doing before. That's all really well and good, but once you've done that, how do you actually distribute the credentials? Well, if you're changing and rotating the credentials on one laptop, but you need them somewhere else, you need a way of getting them over there. I don't want to be walking around with a USB stick to every box. But since they're encrypted with my SSH public keys, which are available from GitHub, I can just push them up to a GitHub repository and then pull them down on that other box, decrypt them with an SSH private key that I have on that box. It doesn't even have to be the same one. Inject them into the environment and carry on. Success. This means that we can have remote credential rotation. It doesn't have to be me that's rotating the credentials. I can have an external third party, a box that I trust, with the rights to inspect the credentials that I have, at least the metadata, see how old they are. It has commit access to the Git repository. It can get my public keys from GitHub, so it can rotate my credentials for me once they get to that half-life. If I'm on a beach in the Caribbean, my credentials are being rotated for me. I come back to work, I run Credulous as part of my normal workflow. It pulls down the GitHub repository, it unlocks the keys with my SSH private key, loads them into my environment. I'm none the wiser. I neither need to know nor care that my credentials have been rotated N times. If I run over by a bus, the company doesn't need to worry because my credentials are no longer valid N hours after I actually stop using them. Here's an example of how it actually works. Everyone likes pictures. We have Amazon Web Services over here. They're actually a lot bigger than that, but excuse the artistic license. This box here is the credential rotator. In REA, people tend to call things, it's not ISA. Inator, that's right. It's something inator. This is not the credentialinator or anything. This is the credulositor.
Why not credinator?
A credinator, it's a credulositor. We have a user there, and we have GitHub, of course, happy hub. So at the beginning, the credulositor makes a query to AWS, and it says, of this user, what credentials does this person have, and how long are they valid for? It compares them to what's in the GitHub repository and says, aha, you have reached your half-life. I will rotate your oldest credentials. So it does a delete and a create and gets new access keys for that user. Goes off to GitHub, gets that user's public keys, encrypts the credentials with the public keys, and pushes them up to GitHub. User comes back from vacation or wherever, git pull, downloads the encrypted credentials, decrypts them with a private key, injects them into the environment, and starts making happy API calls. And all is well in the world. And that's wonderful. And I've covered that already. Ahead of myself. So on the first try, when we decided to write Credulous, we did this at Hack Day 15, which was not the last Hack Day, but the Hack Day before at REA. We have Hack Days once a quarter. And a day is actually more like 2 days. We decided we were going to write it in pure bash because there would be no external dependencies. It would be available everywhere. Absolute fast start, minimal stuff that needed to be done, except for the fact that, of course, it wasn't pure bash because we needed OpenSSL and awk and cut and date and grep and set and all of this sort of stuff. And it turns out that the command line arguments to date are not the same on Mac OS as they are on all the distributions of Linux. Who would have thought? Ridiculous. But it was a problem. So we wrote it for Hack Day 15, and we wrote it in less than 24 hours. And for a prototype, it was pretty awesome. It worked really, really well, mostly. So it had lots of features. We could do local and remote Git repository, pulling and pushing and merging and all of that. We could do encryption with multiple keys pulled from public GitHub or GitHub Enterprise. It didn't really matter. We did credential rotation the way I described, and it didn't really work very well because it was a bit unwieldy. I know that Bash has test frameworks, and I know that you can do all sorts of clever stuff in Bash, and I can do all sorts of clever stuff in Bash, but quite frankly, you don't want to and on a long, ongoing basis. And those of you who have gone from Bash to Ruby scripts to manage your pallet and forklift environments know this. There we go. It has very poor error handling. Things work, things didn't. You end up capturing standard error and redirecting things which only put errors to standard out into this, that, and grepping and stuff like that. And it's already rather ugly. And credential rotation was unfortunately flaky, which means that when credential rotation breaks, you get locked out.
Permanently.
Yeah, well, not permanently, because you can log in by the console or you can have someone else reset your credentials, but it's a pain in the butt, really. And no one wants to have to go through that. And it never got open sourced, which I was sad about. But realistically, you wouldn't have wanted to see it. It would have made your eyes burn. On the second try, for Hack Day 16, in joke there, we decided that we would, in joke there, we decided we would rewrite Credulous in a nice language with no external dependencies, and we would open source it as soon as we possibly could. So we did. We decided on Go as the nice language because it builds binaries with nearly no external dependencies. You have your external shared libraries for libc and libpthread, and that's really it. Everything else is built into the binary. So you do not need to gem install, run setup.py, any of this sort of stuff. You get the binary and it works. We got a lot of eager helpers because when I did the pitch at Hack Day and I stood up and I said, we want to rewrite Credulous, everyone went, and I said, we want to do it in Go, and people went, ooh.
One of them you go.
Sorry?
One of them you go and 6 of them.
One of them you go, and actually, as it turned out, 6 of us didn't. So we did a lot of getting up to speed on Go, and I went from knowing 0 Go on Thursday morning to being pretty happy with it by midday Friday and doing some very cool stuff with Reflection. So that was testament to the power of Go. It's much, much more robust. It's got test suites. It's got reasonably good test coverage, although I need to go back and put some more in now that we've done a bit more extension on it. But it's not as feature complete as the Bash version was. But it's better because it doesn't break in nearly the same exciting ways. So the current status is that we wrote it on the Thursday and Friday of Hack Day, and we open sourced it on the Monday. So straight out there, don't bother polishing it, just get a quick review. Has it got any proprietary confidential stuff in there? Make sure we slap the MIT license on it, put it in the real estate organization in github.com, and open source it, get it out there. Earlier is better, before you actually bake in really bad things. It only supports a local credential store at the moment. It's not, doesn't have the support for local or remote Git repositories. We do have some code that's written against that that's not merged in yet. It has some additional features. You can store environment variables alongside your credentials. So who's ever been in the situation where you do AWS EC2 describe instances and it says you haven't set your AWS default region environment variable? Well, you can store that with the credentials for the region that you most commonly use, or any other environment variable that you would care to. PS1, for example, so that you can set your prompt to a pretty color when you're in this account, and an ugly color when you're in that one. It supports multiple IAM users within multiple accounts. I have 15 combinations of credential sets at last count, and I use Credulous to manage them all, of course. We have a bash wrapper, which does all of the Credulous work under the covers and then sources the output, or evals the output into your runtime environment. We have bash completion. So that's fun. That makes a lot of people very happy. And we are providing RPMs, Debian packages, and homebrew install method for OS X. Ooh, who wants a live demo? Yeah? Okay. I'm going to have to see if, where's it gone? I'm going to have to tether to my phone because it's the only way I can get a reliable connection. But this should work okay. What could possibly go wrong? There we go. Tethering. And let's put that away for the moment. No. Ah, there we go. Right. Now, let's have that. Oh, I like this. I like this projector because when I did this in a demo situation before, the TV I was using cut off this much, and it made it all look rather silly. So here we are. I don't have any AWS environment variables over here, so if I do AWS IAM list count aliases, it says, nah, you haven't got any credentials. So I'll source some. Credulous source, I'm looking at the reflection up there as I do this. I'm going to give it my username, my IAM username, and the account alias, the Amazon account alias. With each Amazon account, you can set a local alias, and those alias names are globally unique. So it's a bit like a land grab. If you want to go grab United Airlines or Oracle or whatever, go out and do it now. It's prompting me for my SSH passphrase, because I have a passphrase on my SSH private key, as do you all.
Password 1.
Not password 1. And it's taking a second here because password 11111. It's taking a second there because what it's doing is I've asked it to unlock the credentials for CMP at Nord. It's unlocked some credentials which in the GitHub repository, on the Git repository, or in the local repository, were for, apparently, CMP at Nord. But I want to make sure that no one's poison pilled me. So I've gone off, and Credulous makes a couple of API calls to Amazon to say, is this really for the user CMP and the account called Fnord? And if it is, then hooray, otherwise it's gonna bail, they won't let me have them. So now I can run my list account aliases command again, and we can see that, ta-da, there are the results. I'll put that up for you to see. There are the results of the API call, and that all works. It was well and good. I can also save these credentials. That's all there is to it. It goes off. You have the credentials loaded into your current environment, the AWS access key ID and the AWS secret access key. It'll go off, query AWS and find out what the username and the account name is, encrypt them with a local SSH pub key and save them into the local store. And that's all very well. Let's put that up there. If I say Credulous source, I can double tab account. So bash completion. These are all of the usernames and accounts that I have in there, which is all well and good. And I can even show you Credulous local CMP. Oh, that's right. I created some new ones. Okay, so here's the JSON that we store it as, and you can see that we support encryptions, multiple encryptions, the list. We store the fingerprint of the SSH key that was used to encrypt this particular blob. This is the secret key, the access key ID, and any environment variables that I defined to be saved as well. And we store some other metadata along with it. So the lifetime, which I currently have set to 0, so these won't ever expire. The creation time, the account alias ID, and the version there is particular to the data format so that we can do forwards and backwards compatible saving. That's the majority of it at the moment. Let's put that up there. Ooh, live demo. So as I mentioned, we still need to implement the local and remote Git repository support. Those of you who've actually tried to code against any of the Git libraries know that I can see that there are probably a few here that might have tried because of the lack of hair. But most of you obviously haven't. It's pretty hairy. I say that we haven't got local credential rotation, except that I wrote that this afternoon, and it pretty much works. But obviously I need better test coverage and better support. It needs to be a little bit more robust. And we need to build the remote credential rotator, the Credulosity. We would like you to please use Credulous and give us feedback and create issues on GitHub or pull requests. If you go to credulous.io, you'll get a rather ghastly page that I put together, and I apologize, which will link you to the README and link you to the GitHub page and a couple of FAQs and things like that. You do need to have a couple of IAM policies in place in order to make it work, but they're fairly trivial things to do. And I would like to open it up for questions.
So how do you manage multiple SSH keys? So you just grab all the public keys and encrypt the data multiple times?
Yep. Okay. So when I showed you the JSON there, the encryptions was an array. So you would have multiple blobs with and each blob would have a ciphertext and a different fingerprint. Yep. So you'll have that covers the scenario where I might have a work SSH key on this laptop, I might have a home SSH key, I might have a third one somewhere else. But the public keys for those SSH private keys have all been uploaded to GitHub. Yep. So then I can go to any one of those systems, do the Git pull, and decrypt the credentials with whichever SSH private key is like.
Would you particularly lose the ability to log in for your servers if GitHub was down?
No, not necessarily. What would happen is, because it's a local clone of the repository, if the credential rotator, if it were a remote credential rotator that had rotated your credentials and then GitHub had gone down, or if you were using a GitHub Enterprise appliance, for example, and it had gone down, then yeah, you might have a problem. But you could also go to the credential rotator and grab a clone of the repository directly from it, because everything in that repository is encrypted anyway. So you can make it a public repo. Yep.
Should we still consider the encrypted values sensitive and try and keep these away from public repositories anyway?
Shouldn't.
Just in case there's some kind of SSH version of Heartbleed.
It's possible. It's possible. But if you want to copy that down and have a go at it, go for it. I'll even encrypt it with a couple of other keys and post it on Pastebin.
Have you ever flirted with the idea of maybe hooking it into like the web of trust with someone here, or is that just too crazy?
It's not crazy, but when you start talking about web of trust, then we're sort of going back down the GPG path again. And the reason why we steered away from GPG was that the process of getting a consistent GPG configuration set up across multiple platforms with a variety of different developers, we thought it was just going to be awkward to get started. So the SSH public key, private key doesn't work with DSA keys, only RSA keys. Everyone has an SSH key if they've ever used GitHub. And so that was a really easy in for us.
How do you add a new key? You already use server.
Yep. So the easiest way to do it is to put the credentials into your current runtime environment and then just say credulous save. And that's it. That's all you have to do. You can specify a different SSH key if you want to use a non-standard one. When you specify environment variables, you can specify multiple ones on the command line, that sort of stuff. So we welcome all suggestions for user interface polish as well.
Because it is a Git repo, if just say your laptop gets stolen, you have your work SSH key on there.
Yep.
How would you revoke that key? Like, how does credentials?
I would just go ahead and rotate away those credentials.
Okay, right.
So it doesn't matter that they've got the key now. I'd revoke the key from GitHub and I'd rotate the credentials that I knew were compromised.
Does it work for AWS and drivers, or technically you could encrypt anything?
Well, technically, if you wanted to jam all sorts of crazy stuff in the environment variables, you could. Someone was wondering earlier today about X509 private keys, and I sternly resisted the urge to suggest feature creep. Someone else came along and said, could we encrypt our SSH private keys and put them in a credulous repository as well? And I was like, it doesn't really do that. That seems risky. Yeah, so you could actually put quite a lot of stuff into that ciphertext block. One of the issues we have right now, and I just logged this earlier today, is that at the moment we are just encrypting the key ID secret and any environment variable sets as a marshaled JSON structure. So how much we can encrypt at the moment depends on the length of your SSH key. For a 1024-bit SSH key, you can only encrypt 117 bytes because of the way it gets padded. But what we're going to do is actually add the mechanism so that we'll generate a secret, encrypt the whatever with that secret with AES, and then use RSA to encrypt the secret so that you can, anyway, arm's reach.
Or does it detect what it means to create that? Does it just look for something that starts with AWS_, for instance?
Yes, it won't look for AWS_ everything. At the moment, it only looks for the two critical ones, the access key ID and the secret key. It doesn't bother looking for session token, because session tokens are for short time limited credentials anyway. Why would you bother storing those?
Does it need to encrypt the environment variables that you store?
We had to think about that, and we thought that there's no harm in encrypting the environment variables, and there are some benefits. It provides a bit more plain text. It makes the plain text perhaps a little bit more random. We don't want people to push this sort of stuff up to GitHub and accidentally include stuff in environment variables that leaks information in somehow. So we thought it was safe to just, jam the environment variables into the ciphertext as well.
I'm just wondering about IAM roles. I don't know how specific behind that, but I was wondering how this part much of that you're working on.
Sure. So IAM roles, the place you would use an IAM role, and IAM roles actually come into play when you're talking about the identity federation there for a user. Roles we tend to use most commonly for persistent automated services like CI servers, that sort of thing, monitoring servers, which might need to go and poke at the APIs, and you put an instance role around that EC2 instance, and all of the credentials stay inside Amazon. They never get out. They're rotated constantly in the toolkits. The SDKs are aware of that. You could use your IAM credentials to assume a role, but the role credentials, when you get them, are time-limited credentials as well. So if it's a SAML role, then they're only valid for an hour. If it's a Get Federation token role, then they're valid for up to 36 hours. But we don't have any specific support for roles, but if you wanted to include the session token as well, then you definitely could. There's no reason why not. It would just only be valid for a short period of time.
Any other questions?
I hear food.